Alright, nerds. Here we are. Last lesson on evolution. And we're now talking about neo-Darwinism, or the modern synthesis. So, by the end of this, what you want to be able to do is, you want to be able to explain what the modern synthesis is, or neo-Darwinism, and you also want to be able to compare neo-Darwinian evolution to Darwinian evolution. While we're here, neo means new, okay? So it's the new Darwinism. Okay, oh, by the way, this here is everyone's favourite. It is... I'm not going to write it out. Yeah, sure, give it a go. This is Archaeopteryx. That's Archaeopteryx. Rad dinosaur. Also a bird. But so are all dinosaurs. So what are the problems with Darwinian evolution? So it's an idea which isn't complete. That's the main problem. And it's got two major shortcomings. These are the shortcomings that were around when Darwin was putting forth the idea. They're not there anymore. First, there's no explanation for how variation arises, how things are different. And there's no explanation for how variation is passed on to the following generations. Now, there is another topic which came about and solved this problem as well. So, in the 1940s, a couple of geneticists put forward a synthesis between Darwinian evolution and Mendelian genetics. So this is Gregor Mendel, and he was a pretty big deal. He was the dude with the P's. They called this either the modern synthesis or neo-Darwinian evolution. So what is it? Essentially, there are two aspects of it. One, there's the Darwinian evolution. This is the stuff we already know about. So we've got evolution by means of natural selection. That's not new. And common ancestors / descent. Then Mendelian genetics kicks in. You've got random genetic mutations. We know these happens. So that's where we get new adaptations appearing. And we've also got chromosomal theory of inheritance, which means this is just how that DNA is passed on from one generation to the next. So, I can explain with the two equations. Now, you don't need to know these. These are just very, very interesting. Actually, no, you do need to know those. Sorry, my bad. Know these. We've got random genetic mutations plus inheritance equals heritable variations. In other words, when we get a mutation and we can inherit it, we get a variation which is able to be passed from one generation to the next. So then you use your heritable variations plus natural selection and time, which gives you an adaptation. In other words, you might have long wings and short wings. These are your two heritable variations. Natural selection prefers the long wings, and over time, eventually, you'll get a species that is mostly, if not all, long-winged. And that's it. That's pretty simple. Alright, I'll see you in class.